Hello and welcome back, everyone. This is going to be the final drawing file lesson in the group of drawings known as the control bracket, right angle brace, and die punch. So this is our introduction to Inventor solid modeling. So we've modeled all three of these. Now we need to finish the last drawing file excuse me, for this part. So this one here is a combination of fractional units and decimal units. So we're going to have to do a little more with setting up our dimensions on this final drawing, because we're going to represent them the same way they're seen here in this image. So to get started, I already have it open in Inventor, which is your first step. And we're going to go to File, select New, New, and make sure we're in English tab under Templates and select ANSI-INCH.IDW and hit Create. And we're just waiting for this to load up. All right. So this defaults to a D-size sheet. We've talked about this in the previous two lessons for drawing files. We need to reduce this size. This is way too large. So we're going to go to Drawing Resources, click Sheet Formats, and again, like the right angle brace, we're going to select B-size to view. Hit OK. And this is going to flip us to a B-size sheet, and it's going to bring in two of our three orthographic views already, knowing that the front view is the view that will control the right side view. So we're going to bring this down. And we're going to need to create a top view. So we're going to right click in the front view, click Create View, Projected View. Bring this up, left click, left click, Create. All right, so we've got our three views. We also need to create the isometric view. So a lot of this is review from what we've seen before. So we're going to right click, front view again, highlight Create View, go to Projected View again, and then drop this isometric view in the top right hand corner. That's the correct term for this. And select Create. Now, this is too large. We're going to scale it down because it competes with the two-dimensional orthographic views. It takes up a lot of space as a one-to-one scale view in isometric mode. So we're going to double click it, reduce the scale to 3/4 here. Click OK, and we're going to tuck it further up into the corner like this. All right. So we continue to review drawing files with this lesson. So we need to create center line annotations next. Now this is before we create dimensions. So we're going to click over to Annotate, and we're going to start with a center line with the top view. Now the reason for this is a symmetrical view. So if I cut it right in half along its length, it's basically a mirror image. So what I'm going to do, grab the center line, find where it snaps right here, that green circle, and bring it forward to this one. Left click again, right click, and hit Create. And what we also can do is create a center mark right here as well. And these center lines here, they don't really need to extend all the way out like this. So what we can do is we can just shrink these in a bit and try to match it up as best we can with what we see here with this center mark. So we're just gonna trail these up a bit so it looks somewhat close, as close as we can get it. All right, so that looks good. Continuing on with center lines, we're going to create a center line here and here because this is a hole. Anything round requires a center line. So we'll use the bisector this time. This would be simpler. So we'll select it, select this hidden line and this hidden line, and it will add it for us perfectly. This one, and this one, and this one, and this one. All right, those are all the center lines for the front view. We're working on the right side view. We're going to do the same thing again. create a center line, find the mid snap here, and come down vertically to the bottom, find the snap here, left click, right click, left click, create. And we're also going to add a center mark here. All right, so again, I always have my center line pass through the entire view of the object if it has symmetry. And again, this is another case of symmetry. This view here has no symmetry, so we're only showing center lines on the hidden feature holes here that cannot be seen when looking at this from the right side. All right, before we start dimensioning this, we're going to fill the title block in because that's fairly simple. So again, a review of title block creation in our sheet. So we're going to File, clicking iProperties, tabbing to Summary, and then fixing my name here. So first initial, all caps, period, space, my last name. And you're going to notice, and if I haven't mentioned this before, you're always typing in all caps. You're never using any lowercase letters. So drawings always have uppercase. Title blocks, notes, it's all screaming. That's just the way it is. So this is the control bracket, and the company is our school name, Ancaster High. Click over to project. This is an original, so the revision is 0. The part number, we're using 3M1, the last 3 digits of our course code, dash, and this is our third drawing, so it's 03. Click to status. Your drawing checker's name will be added here, and check on the date that they're going to be checking it. So I'm assuming mine will be checked today, September 30. Apply, close. All right, so we take a look at this, make sure everything went where it needed to go, and it has. So now we're ready to start dimensioning this. So we're going to have to create another dimension standard for this. So when I click General Dimension to begin, it shows here on the right, this is by stan, meaning by standard. Right? So if I run a dimension just like this, here, let's say I'm going to start with these holes here. So I'm going to run a dimension from here to here. I'm going to pull it up. And watch for when this breaks, right? You want this to break. So when I pull this off, this is too close. So right about here is okay, or I could go a little more. I like it right here. But the thing is, you have to be consistent, right? You have to make your spacing consistent everywhere, right, for professionalism. So when you're running these dimensions, you really got to be careful and watch for that break point where it turns dotted. It's too easy to do something like this. Like drop a dimension right here, not give any thought to it. Okay, that's too close. Right click, left click, okay, I just want to escape. And what if I dropped it way over here, right? Like this is too far away. So you really have to use inventor's hints here to help you along the way. Okay, so that one is 1.5. We're showing a 0 on the end, but that's fine. Okay, so let's say I want to have a fractional dimension. Right, I'm going to want to show the fractional dimension here. From the top of the surface of the right side view to the center of the hole. Now there's a reason I'm picking these particular spots for dimensioning. We're going to have to talk more about this because if I talk too much, the video becomes way too long. So I'm trying to avoid that. We're just trying to get some practice in right now. So we're going to click Dimension, select this horizontal line and this endpoint of that center line. And again, this is a decimal, and it breaks right here. Hit OK. right? That's very similar spacing to what I'm showing up here on the top view. But I want this to be a fraction. So right click, left click, OK. So what I have to do is basically click this dimension after I've exited general dimension. And I don't want to have to do this one by one because that's going to be too much work. I want to be able to have 2-dimension setups that I can go between if I need to, because it's very time consuming to like make every single dimension an edit. So we're just going to edit the one. So we're going to right click it and we're going to scroll down. Instead of editing the dimension style, we're going to create a new dimension style. And we're going to have to give this a name. So basically you could call this one, so it says default ANSI, we could call this one fractional. And you could even throw your name on here if you want. It's up to you. I'll do that because I'm making this one. And we're going to change the format from decimal to fraction diagonal because this looks the best. We're going to reduce the precision to 1/16. Now this is to prevent crazy amounts of rounding when you're running the dimension. We don't want it to round to a nearest quarter. That's too much. That's too permissible for error. We want to actually have the precision of a 16th, which is generally what you'd find as acceptable. We're going to click to this alternate units, change precision to 0, go to text. We're going to add a suffix on the end. So this is for English units. We're going to hit OK. And there we have it. So it automatically updates this dimension for me. Now we're going to be able to go back and use this whenever we want. To continue on with this, I'm going to run a dimension. I'm back to standard. So when it defaults to standard. So this is going to give me a decimal dimension. So I'm going to click from this center line to this line, and it runs the 1.75. And notice it wants to kind of break. It just naturally wants to just rest in line with that 3/4. So I'm going to click, left click, and run that dimension, and I'm happy with that. So this is 3/4 inches in fraction, 1.75, 2 decimal places in a decimal form. And that's what we see here. Right, so there's the 3/4, there's the 1.75. It's dimensioned along the right side view, looking in this direction. Now the reason I have mine over on the right is because it's a good idea not to put dimensions between two views if possible. So if this is going to look exactly the same on the left side and it crowds two views, I might as well clean it up and keep it to the outside on the right where it doesn't crowd anything. So this is something we're going to talk more about later, but I'm going to discuss some of my dimensioning styles as I go through this to kind of help you learn how to do this. So that takes care of that one. We also have a 1.75 dimension from here to the center line. You're going to notice that if you run these dimensions properly, if you click this line here, which is fine, but I click the top of the center line. I don't click into the middle. If I clicked into the middle, the extension line would run over half of the circle over the center line, and we wouldn't see this gap, right? If you snap these dimensions properly, you get this gap automatically, right? This is something that Inventor does for you, and this looks very proper. Right, so watch for this when you're running your dimensions. So we've got our 1.75. It makes sense to chain that up on the outside of the top view with the 1.5. Right, here's the 1.5 in the same position I've dimensioned it. Here's the 1.75. It makes sense to keep it on this side outside of the views chained to this one. All right, so There's a method here, right? I'm doing a better job dimensioning this than it's seen on this image that you work from. Continuing on. And I also have this open on my iPad next to me, so I'm looking at that next to my screen at the same time I'm working on this. So what do we have left to do? We got a few dimensions. We have to show a radius or a fillet of 5/16. So what we're going to do is hit dimension. We're going to click the arc here, the radius, and we're going to pull this dimension off. Now, these ones are a little bit harder to do, right? Because they don't really break. So basically you don't want to crowd it. You don't want it like super, super close, but you don't want it far, far away. You want it to be somewhere around here, right? Basically similar to the distance we've been choosing while running these other dimensions, right? We want it to look consistent. Now, here's an issue. R.31, this is in decimal form. This is supposed to read as a fraction. This is what they're talking about, this fillet right here. This is supposed to be 5/16. So what we're going to do is right click, left click OK to exit. We're going to select this dimension, go to our drop down list and select the one I created, and that is going to turn that one exactly to where it needs to be, right? So that's why we create that our own dimension editor for fractions, because we want to be able to toggle between two different styles. It's always going to default to the standard unless I select this one to go first. So moving forward. Also, I just want to mention these two dimensions here that I've already run. I can't put them on the left side of the front view because it's incorrect to dimension anything on a drawing to a hidden detail line or to a center line that's even associated with a hidden detail line. So that is a complete no, as in negative. So you should never, never, ever run any dimension to any hidden feature on a drawing, even a center line associated with that feature. I say it again. There's some gray areas in dimensioning, but that is not a gray area. If you ever see it, it's incorrect. So I'm kind of a stickler for this kind of thing. Moving on. The 3/4, we wanted to be able to show the thickness of this rear flange that comes out of the control bracket. So we have a couple of spots we can show it. We could show it here or here. Now I'm going to show it here. And again, so this comes up as a decimal. So if I hit dimension, come down here, hit fractional, this is going to run it as a fractional dimension right from the get-go. Right, we're trying to get this to be similar in appearance. Now, I'm just going to drag this up a bit. Now, this looks better on this view. Right, I could have dragged this dimension up and then put it here, but it's better understood on the front view. Again, it's dimensioned to an object feature, which is physical outline of the part, but it's better to put it on a view where there's a defined profile. It's easier to understand a dimension like this if it's placed where we see a clear, distinct profile of the part. I know it's also a bad idea to put dimensions between views. We've talked about this because it creates some crowding, but one dimension isn't really going to crowd, and we can place dimensions between views if we want, if we have a good reason to do so. And this is one of those times, right? This dimension is better understood here, so we don't need to run it up on this view where there's just flat 2D view perspective. right? There's going to be another example of this later. We're gonna take a look at as well. So that's the best spot for that dimension. Moving forward, we have to show the overall length of this part. So there's a couple of ways that we can do it. We're running really low on room here on the top view. So it's best to run that dimension here on the front view. So we're going to go from here to here. And we're going to drop that overall length. And we also need to show this dimension here. This is a 2.63 dimension. This is also on the sheet right here. Now, it doesn't have an overall listed, but we always have to include an overall length and an overall thickness and an overall width when we dimension any orthographic drawing. So I've already started with one, right? So we have to add this dimension in. It's really good to have a clear indication of how long something should be. So the person in the shop who's manufacturing this part, they know how much to cut the stock off at the saw, right? So an overall dimension really is super important. And we may modify this because we're going to talk about this in a moment. This 3/4 and this 1.75. We're probably going to make an adjustment, and I'm going to discuss what it's going to be. Okay, so moving on, we also need to show the height here. Now this should be in fraction. So we're going to hit dimension, hit fractional, pull this dimension off right here. And we're also going to dimension from here to here. And that 1/4 inch. Now let's try that one again because it's kind of running where it shouldn't be. Let's click this back to default fraction. Click from here to here. This is better, right? Okay, so right there. There. We want to add that up right in line with this. So from here to here is 5/8. This arrow to this arrow represents that this space is 1/4 inch. And you see that here and here. And this is placed on the best view possible. Again, where there's a profile of the view. These dimensions could be placed over here. Now, if I drop this dimension here, meaning I delete it, and I was to do the same thing, run that dimension, let's track that one to here. Put it in line like that. Now it is a bit crowded here. We could bend it like this to get it to fit. I hope. All right. Now let's look at these two. This is considered over-dimensioning. So I don't need to repeat any dimension twice on any more than one view, right? Because then the drawing is going to become way too cluttered with dimensions. The reason I did this is to show you two possibilities. Technically, they're both correct, but one is better than the other. And when you look at this, I think when you look at these two from the front view, it's easier understood where the profile is, right? We have the extension line running, showing here the height of this part of the base, and then we have an extension line running from here and running to here, which shows that rabbet joint that's sitting right here. It does the same thing on the right side view, except it's just, again, flat 2D perspective here. And again, we're dimensioning between two views, but this is okay if there's an advantage. And I think there is an advantage to have these dimensions shown here on the front view than here. So we are going to drop these dimensions here because that's over dimensioning. We're going to keep them on the view that they look the best, and we're going to move on from here. Moving forward, we need to identify the holes here. So there's 3 holes all the same size. So we're going to run a dimension. Again, this is going to be a fractional dimension. And what we can do is just come up here and touch that, and then we can keep that in line like this. And what we want to do is, the sheet says 3 holes. The more professional way to do this would be to space and then type in all caps tip, short for typical. So what this means is the person in the shop knows that this diameter of this hole is obviously the same here and the same here, right? It is the same size, and instead of saying 3 holes or running the dimension here, here, and here, over dimensioning the drawing, a typical allows us to get away with doing less when creating dimensions, right? Obviously, if the hole was a different size somewhere else, we'd have to run a dimension to it, but this is good enough, and this satisfies dimensioning all 3 holes, just like this, just doing it once. We also have to identify this radius value here. And we're going to have to do this off of the part, off of the view. This 5/8 here, it sits right on top of the front or the right side view, depending on where you think it is, because it's a radius here. But we always want to pull all the dimensions off of the view. You're going to notice I don't have any dimensions sitting on any of the views. They always have to sit outside. They have to break as you're pulling them off of the part. So something like this, even though it shows it kind of like this on the sheet, this is incorrect, right? So this is not allowed. So we're going to be deleting that one. We're going to go back into dimension, hit fractional, and we're going to identify the radius here. We can do it up here. We can have it down here. So I think it looks best if we keep this one somewhere around here. Now, this does not crowd between two views. It basically, if you ask me, it looks better down here. I mean, we could, if we run it again here, again, I don't want to crowd this, right? I mean, you don't want to crowd these. You don't want to have it like this. You want it to kind of be in line with the 5/8, but you don't want it to be too close to the part. So in other words, if we run it down here, we can kind of get it a little bit of proper distance away, and we can still line it up with that 5/8. So this is, to me, this looks more professional. And we also need to show the 1/2 inch radius arc here. So we can only show that on the right side view because there's no perspective of it anywhere else on the top or the front view. I'm going to run it twice, and we're going to keep the best option. So we're going to go, again, this is fractional. So we're going to select this arc. We're going to run a 1/2 inch here. Try to line it up on top of that 3/4, about 12 millimeters away, or an appropriate similar distance to what we see here. And we're going to do it again. Let's touch here. I can't pick it up. Okay, so we're just going to do that. All right, so we don't need a typical because the center line tells the story of symmetry. But again, we don't need two of these. What looks best? Well, this one here, this arrow leader crosses over this 3/4 dimension extension line. So what I'm going to want to do is keep this one because this one is cleaner. Again, it's not really between two views. It sits up high. And this one here, I would say this is the one you want to keep, right? Just based on this doesn't look so nice. So we're going to delete one, right click, left click, OK. We're going to select this one. We're going to hit delete and get rid of it. Now we should pretty much now have about every dimension needed. I'm just going to save this. I'm getting a bit of, this is nothing to do with the drawing. This is just my computer acting up right here. So I'm going to hit save as. I'm going to save this into the same folder I've been working with, the other two drawings. And that, when I save it, it kind of clears that up for me. So I've got every dimension on here almost. I just need the overall width. It's listed as 2. And again, there's no decimal value, and I'm going to assume this is a fractional dimension. So what I'm going to do is go back to annotate, hit dimension, grab fractional Lemieux, and click this endpoint and this endpoint, and bring that off like that. So I've got my overall length. I have my overall width. I need my overall thickness or height. So we're going to run that dimension here. Now that dimension could also be run here. It's up to you. I just don't have a lot of dimensions on the right side view, so I thought that I would space them out a bit. But originally I had a 1.75 dimension here. Now if I put that dimension back and just go by standard, which is going to give me decimals, this is what we see on the image in the hub, right? These two. Now, the way you see this is incorrect. Why is this incorrect? Because this is, again, over-dimensioning. If I have a dimension here from top to bottom, and I know it's 2.5 inches, and I have this fraction, this decimal dimension, this is too much information. This is like the same thing repeated, just broken up over two sizes. So because I need to have an overall dimension, which is the height, I have to drop one of these dimensions. It doesn't really matter which one I drop. You could drop the 3/4 or the 1.75. I think I'm going to drop the 3/4 because a decimal value is more precise than a fraction in terms of manufacturing. So I think the whole will be better taken care of by the person in the shop if they see a decimal value versus a fractional. So I'm going to right click, left click, OK. I'm going to select the 3/4 and we're going to hit the delete key or right click and select delete. And that's going to take care of that. So, and that's pretty much it. I'm just going to finesse this a bit just to kind of make it look consistent everywhere. When I look at this, I want it to be consistent, right? The spacing, I don't want some dimensions to be way out in the breeze and other ones closer, right? It's all about professionalism. So we're going to take one last look and make sure everything is accounted for, and it looks like it is. So, and even if you ran this dimension on the front view on the left side, which is also fine, it doesn't make it okay to keep that 3/4 dimension here, right? It's still considered over-dimensioning. Over-dimensioning is just not specific to a certain drawing view. It's specific to the entire drawing itself. I keep zooming in and out of this. Hopefully you're not going to get sick. Okay. I think we're done. So we're going to hit save. Save it. We're going to go to save as, save copy as, and we're also going to create a PDF version of this and hit save. And that is your lesson on how to properly orthographically complete the drawing file and dimensioning for the control bracket. So try this out. Good luck. Any questions, please come and find me. And take care for now.